Hello, welcome to this introductory video of my course Advanced Dynamics. My name is Anirvan Dasgupta and I am going to discuss a little bit about what I am going to cover in this course. I am from the Department of Mechanical Engineering at IIT Kharagpur. The first question that must come to your mind is why should you do the course? Let me try to motivate you a little bit. You already know that we are trying to achieve high speed in everything that we do, in high speed railway system, high speed cars or high speed machinery. We have substantial dynamic effects and we must know how to model this dynamics, how to find out the dynamic forces and hence have improved design or understand the behavior of the system when the system moves at very high speeds. So, this is very essential in design of high speed machinery, high speed automotive systems, high speed railways and aerospace systems. We need this calculation of dynamic effects or dynamic forces for proper design. Now, this is an engineering reason or engineering aspect to studying dynamics, why we should study dynamics from the engineer's point of view. But there is another reason I can tell you for which we must study dynamics, that is to understand natural phenomenon such as cyclonic circulation, how cyclonic circulation builds up, why do winds suddenly start a cyclonic circulation, when a low pressure is formed why do they start a spin, why do tides form, how tides are formed, but due to the attraction of the sun and the moon, how does it work out, what are the kind of forces that act on the water that forms tides. Then the precession of the earth or the precession of the boomerang, why a boomerang returns back to the thrower if it misses the target, how tops precess, how earth precesses. These are the things that can be analyzed by knowing dynamics or studying dynamics. Without understanding dynamic forces, especially rotation, you cannot answer some of these questions. Now, what are the prerequisites? Let us look at the prerequisites for this course. You must have gone through a course in undergraduate mathematics and undergraduate mechanics. These two are essential for this course. Let me give you an overview of the coverage, what I am going to cover in this course. The coverage can be broadly divided into three parts. The first part is Newtonian dynamics for particles, second is the Newton-Euler dynamics for rigid bodies, and finally, we are going to discuss analytical dynamics formulation of Lagrange. I will start with kinematics. As you know, dynamics is a study of kinematics and kinetics. Kinematics is a study of motion without reference to forces, whereas kinetics is the study of effect of forces on particles and rigid bodies. I am going to start with kinematics. I am going to look at kinematics in non-rotating frames, which are also called inertial frames, and non-inertial frames, and rotating frames. And I am going to then go over to kinetics, first for particles, then for rigid bodies. We are going to look at conservation laws that can be derived from Newton's equations and Euler's equations, and in the third part we are going to look at an entirely different formulation of dynamics as done by Lagrange. This branch of dynamics, also known as analytical mechanics, takes dynamics to the realm of analysis in mathematics. Now, there are a few reasons why I am going to give you the whole gamut of dynamics in this course. You must have studied dynamics right from schools and possibly in your undergraduate mechanics, but you have learned it in different ways, in different contexts possibly, and with different motivations. In other words, you all are now on different platforms as far as understanding or approach to dynamics is concerned. I would like to bring all of you to a uniform, a common platform before you take the leap. So, in order to unify how we understand dynamics, how we derive various concepts, formulations, I want to unify all that. That is why I will start from absolute basics, and it should be very useful and helpful for you to build the foundations of dynamics in this course. Secondly, I am going to talk about applications of these sometimes familiar concepts to natural phenomena, to understand natural phenomena like cyclones, tides, how we can understand even based on very simple dynamics, which was never discussed possibly in your undergraduate mechanics, that I am going to discuss here. So, this is more or less the overview of the coverage of this course. This course will be a 12-week long course, which is a 30-hour course. There will be weekly assignments, and I strongly urge you to, if you take this course, I strongly urge you to do these assignments, and then there will be a final examination for evaluation. So, these weekly assignments and the final exam will go into your overall assessment in this course. A little bit about the lectures. In the lectures, I will explain a concept and also take examples to further demonstrate those concepts. So, I will take example problems, and it is here when you are listening to these lectures, I suggest not to take notes during that time. You must understand the concept, and later on you should be able to repeat that yourself, repeat the problems yourself, and that will be real learning of the course. Now, if you are convinced, if you meet the prerequisites, if you think that this course is going to be useful to you, which I hope it will be in building your fundamental concepts in dynamics, and you are going to take this leap to more advanced things, then I welcome you to this course, welcome you on board with me in this course. Thank you for your attention.